All right, so we are reviewing the area of our rigid shapes as well as the area of a circle. So the first thing, remembering that area is the space inside two-dimensional shapes. So if you have a rectangle, if you have a parallelogram, if you have a triangle, trapezoid, and circle, the area is all of the space inside the walls of those respective shapes. Now, each shape that we have on this list has a different formula, but they're all very similar, except, of course, the circle. It's because the circle is special. So we take a look at a rectangle. Rectangles are determined, their definition is that they have four sides, parallel lines, parallel sides I should say instead, sorry, our last unit was angles, parallel sides, and that their angles are all 90-degree angles all the way around the shape. The area formula is base times height. You have your base, you have your height. What we're looking for is this 90-degree angle, or any of them for that matter. And that 90-degree symbol is what tells you your base and your height. Lucky for us, rectangles, because they have all of them, we could basically use any two sides. The height and then this side and that side, this side and that side. Basically any sides that aren't the same. So you can't use the base and the base because those aren't connected by the 90-degree angles. A parallelogram is a very, very similar shape to a rectangle. It also has four sides, as you can tell. It also has parallel sides, but it doesn't necessarily have 90-degree angles. These two angles happen to be the same, and these two are the same. So find the area of a parallelogram. Turns out that it's the same as a rectangle. It's base times height. But what you have to be careful about with parallelograms is that if we have this side be the base, this bottom line right here, the height is not the slanted side. The height is the distance from the base to the highest point on the opposite side, 90 degrees away. So what I like the most is when we draw in that line right there, it's called the altitude. This 90-degree angle actually makes the letter H. So there's your height, and the bottom line is your base right there. That same notion is true for our triangle. The area formula for a triangle is base times height divided by 2, but the base doesn't necessarily have to be the bottom edge. The base is the line that is connected to our height. So in this triangle right here, if I say the bottom line is the base, then the height goes straight up from the base to the very tall point of the triangle. So there's the height. But if I were to draw another triangle, like this, almost identical to that one, but instead I draw my height right here, that makes this edge right here the base. It is whatever two sides are connected by this 90-degree angle. Trapezoid area is equal to base 1 plus base 2 in parentheses times the height divided by 2. So trapezoids are special because they only have one set of parallel sides. The top and bottom line are parallel while the other two are not parallel to each other. This top parallel line is called base 1, the bottom line is called base 2, and the height is the distance between them. Once again, we're looking for that 90-degree symbol right there. But every time we make the 90-degree symbol, we're basically throwing up the letter H right here in our rectangle. There's your height. Parallelogram, there's your height. Triangle, there's your height. Sideways H if your triangle is a little bit crooked. Base 1, base 2, and your height. The final shape, circle, completely on its own. Its formula is pi r squared. R is the radius. It is half the distance from the center dot to the line right here. So it's halfway across the whole entire circle. So from the center to the outside edge is radius. The entire distance would be known as the diameter, and we don't want that. We just want radius. So let's practice a few area problems. Here I have a rectangle, 90-degree angle right there. So that's connecting our base and our height. So here's base on this end, height on this end. Let's say the base is 12 centimeters, height is 7 centimeters. So we're going to record our formula, base times height. We're going to plug in the numbers we're going to use. 12 times 7 gives us 84. We want to include our units, so that's centimeters. But whenever we're talking about area, it's not just centimeters, because centimeters is a distance. We want area, so we say centimeters squared. We're basically going to divide up this entire shape into tiny little squares. Then once all the squares are through the picture, I actually need one extra one compared to the picture because there's supposed to be 7, but I only drew 6. You have all these, you could count them up, 1, 2, 3, 4, blah, 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 blah. There will be 84 of those squares in the picture. Try a parallelogram. So if we have these dimensions to our parallelogram, this is 10, this is 6, that's 10, this is 6, and I want to find the area of our parallelogram, which is base times height. I only have base right now. I don't have the height because I don't have that 90-degree symbol. So I want to go from the very bottom to the very top straight up. Our height of this one is going to be 5. 10's our base, 5's our height. We multiply them together and we get 50. Now when units are not specified, so we don't know it's inches or centimeters or meters or any of those, we play the very general game and we say units squared. If we don't label it, then someone else could come by and label it completely incorrectly and make us get the problem wrong. Triangle. So let's say we know this side's 7, this side's 8, this side's 9. Again, we don't know any of them are the base or the height. What we need to find is our right angle symbol. So we see that this gets drawn in. And when this is here, so there's our 90-degree symbol, it's telling us that 6 is one of the numbers we're going to use, and 8 is one of the numbers we're going to use. 7 and 9 are extra information that we do not need. So area is equal to 6 times 8 all over 2. That's 48 over 2. So the area is 24 units squared. Let's look at a trapezoid. Once again, for the trapezoid, we need to know this edge, and the distance between those two edges. Top edge up here is going to be 5. Bottom edge down here is going to be 7. Height in the middle is going to be 2. Scratch that. Let's make it 3. Makes it a little more interesting. We're going to make the height 3. Area of a trapezoid, base 1 plus base 2 times the height divided by 2. 5 plus 7 times 3 divided by 2. The parentheses are super important. You have to add these two numbers first before you can multiply or even divide. We add them together, we get 12 times 3 divided by 2. So that's 36 over 2, or just 18 units squared. Last but not least, we have our circle. And what we need to know about our circle is this line right here, radius, and it's going to be 5, and then 5 feet. To find the area of a circle, area is equal to pi r squared. We're going to take our radius, plug it into the formula. 5 squared is 25. And then here's the best part about circles and anything that has to do with pi. We can multiply it out using an approximation for pi. Pi is roughly 3.14. We know that it's a never-ending decimal. 3.141592665. Oops, 65. ... That's as many as I know before I don't know the next one. It might be a 4, could be a 3. I'm not 100% sure the calculator ends. So it's right there. But if we were to use any of these numbers, we're getting an approximation. But what we want is an exact answer. So we're actually going to leave our answer right here with 25 and pi right there, and we're done. This is known as leaving your answer in terms of pi. If you ever need to multiply it out, the problem or whatever situation you are in will call for one of an approximation of pi. The more accurate you need your exact answer, so if you're like, 25 pi, I need it to be multiplied out, the more decimals they ask you to include, the more accurate your answer. So using these ones is pretty accurate, even more accurate, but using the pi symbol is an exact answer, and that's what we want. We want the exact answer.